Python functions, building blocks of code. What is a function? A function is a reusable block of code that performs a specific task. It helps to organize code, improve readability, and promote code reusability. Syntax. Def function _name, parameters. Docstring, explains what the function does. Hashtag function body. Return value hashtag optional. Def, keyword to define a function. Function _name, name of the function, follow naming conventions. Parameters, optional input values to the function, comma separated. Docstring, optional string describing the function's purpose, recommended. Return, optional keyword to return a value from the function. Example. Def greet, name. Greets a person by name. Print, hello, name. Greet, Alice, hashtag output, hello, Alice. Key points. Functions are defined using the def keyword. Parameters are placeholders for values passed to the function. The return statement is used to send a value back from the function. Docstrings are helpful for explaining the function's behavior. Types of functions. Built-in functions, predefined functions like print, len, max, etc. User-defined functions, functions created by the programmer. Recursive functions, functions that call themselves. Lambda functions, anonymous functions defined using the lambda keyword. Example with return value. Def add, x, y. Adds two numbers. Return x plus y. Result equals add, 3, 5. Print, result, hashtag output, 8. Benefits of using functions. Code reusability, avoids writing the same code multiple times. Modularity, breaks down code into smaller, manageable units. Readability, improves code organization and understanding. Testing, easier to test individual functions. Collaboration, enhances teamwork by dividing tasks. Want to learn more about specific types of functions or how to use them in different scenarios? Feel free to ask. Here are some ideas for further exploration. Recursive functions, example factorial, Fibonacci. Lambda functions and their applications. Function parameters, positional, keyword, default, arbitrary. Scope of variables, global, local. Function decorators. Python lambda functions. What is a lambda function? A lambda function is a small, anonymous function in Python. It can take any number of arguments, but it can only have one expression. The expression is evaluated and returned. Lambda functions are often used for short, simple operations. Syntax. Lambda arguments, expression. Example. X equals lambda a plus 10. Print, x5, hashtag output, 15. Breakdown. Lambda, keyword to define a lambda function. A, argument to the function. A plus 10, expression that is evaluated and returned. Why use lambda functions? Concise, they are ideal for short, one-line functions. Inline functions can be used directly within other functions or expressions. Functional programming, often used with higher-order functions like map, filter, and reduce. Common use cases. Sorting. My_list equals 1, A, 3, C, 2, B. Sorted underscore list equals sorted, my underscore list, key equals lambda x, x1. Print, sorted underscore list, hashtag output, 1, A, 2, B, 3, C. Filtering. Numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Even underscore numbers equals list, filter, lambda x, x%2 equals 0, numbers. Print, even underscore numbers, hashtag output, 2, 4, 6, 8. Mapping. Numbers equals 1, 2, 3, 4, 5. Squares equals list, map, lambda x, x2, numbers. Print, squares, hashtag output, 1, 4, 9, 16, 25. Important points. Lambda functions are expressions, not statements. They cannot contain multiple expressions. They can be assigned to variables for later use. They are often used with higher order functions like map, filter, and reduce. Python arrays, a closer look. Understanding arrays in Python. While Python doesn't have a built-in data structure specifically called an array like in languages like C or Java, it does offer several ways to handle collections of data. Lists, the most commonly used data structure. They are versatile, can hold elements of different data types, and are mutable. NumPy arrays, for numerical operations, NumPy arrays are highly efficient. They are fixed-size collections of elements of the same data type. Lists as arrays. For most general-purpose array-like operations, Python lists are sufficient. Creating a list. My underscore list equals 1, 2, 3, hello, true hashtag a list can hold different data types. Accessing elements. First underscore element equals my underscore list 0 hashtag accessing the first element. Last underscore element equals my underscore list dash 1 hashtag accessing the last element. Modifying elements. My underscore list 2 equals world hashtag changing the third element. Slicing. Sublist equals my underscore list 1:4 hashtag creating a sublist. NumPy arrays for numerical computations. When dealing with large numerical datasets and performing mathematical operations, NumPy arrays excel. Importing NumPy. Import numpy as np. Creating a NumPy array. My underscore array equals np.array, 1, 2, 3, 4, 5. Key advantages of NumPy arrays. Efficient numerical operations. Broadcasting. Indexing and slicing. Vectorization. Example. Import numpy as np. Hashtag create a NumPy array. Numbers equals np.array, 1, 2, 3, 4, 5. Hashtag perform operations on all elements. Squared equals numbers 2. Print, squared, hashtag output, 1491625. Choosing the right data structure. Lists, general purpose, flexible, can hold different data types. NumPy arrays, optimized for numerical computations, efficient for large data sets, fixed data type. Which data structure should you use? If you need to store a collection of elements with different data types and perform basic operations, lists are sufficient. If you're working with large numerical datasets and need to perform complex mathematical operations, NumPy arrays are the way to go. NumPy arrays offer significant performance advantages and capabilities for numerical computations. Would you like to focus on basic array operations, creation, indexing, slicing, reshaping, mathematical operations, arithmetic, statistical functions, linear algebra, advanced features, broadcasting, masking, vectorization? Let's tackle a NumPy problem. Problem. You have a data set of temperature readings for different cities over a month. The data is stored in a list of lists, where each inner list represents a city and its daily temperatures. Your goal is to calculate the average temperature for each city and find the city with the highest average temperature. Data. Temperature_data equals 25, 27, 23, 28, 26, hashtag city A. 30, 32, 29, 31, 28, hashtag city B. 22, 24, 21, 23, 25, hashtag city C. Solution using NumPy. Import NumPy as NP. Hashtag convert the list of lists to a NumPy array. Temperatures equals np.array, temperature_data. Hashtag calculate the average temperature for each city. Average_temps equals np.mean, temperatures, axis equals 1. Hashtag find the city with the highest average temperature. Highest_temp_city equals np.argmax, average_temps. Print, average temperatures, average_temps. Print, city with highest average temperature, highest_temp_city. Explanation. Import NumPy. Import the NumPy library for array operations. Convert to NumPy array. Convert the list of lists to a NumPy array for efficient computations. Calculate average temperatures. Use np.mean with axis equals 1 to calculate the average temperature for each row, city. Find city with highest average temperature. Use np.argmax to find the index of the maximum value in the average_temps array. Would you like to try solving this problem or explore a different one? Import NumPy as np. Import scipy.endimage. Hashtag create a sample image, replace with your actual image data. Image equals np.random.randint, 0, 256, size equals 100, 100. Now, we can apply the Gaussian blur using scipy.endimage.Gaussian_filter. Blurred_image equals scipy.endimage.Gaussian_filter, image, sigma equals 2, hashtag adjust sigma for blur intensity. This will create a new NumPy array blurred_image with the applied Gaussian blur. To visualize the image, we can use the matplotlib library. Here's the code. Import matplotlib.pyplot as plt. Hashtag. Previous code to create the image and blurred image. Hashtag display the original and blurred images. Fig. Axis equals plt.subplots, 1, 2, fig size equals 10, 5. Axis 0.imshow, image, map equals gray. Axis 0.set_title, original image. Axis 1.imshow, blurred_image, map equals gray. Axis 1.set_title, blurred image, sigma equals 2. plt.show. Would you like to experiment with different sigma values to see how it affects the blur? We can create a loop to apply the Gaussian blur with different sigma values and visualize the results in a grid. Import NumPy as np. Import scipy.endimage. Import matplotlib.pyplot as plt. Hashtag create a sample image. Image equals np.random.randint, 0, 256, size equals 100, 100. Hashtag different sigma values to experiment with. Sigmas equals 1, 2, 3, 5. Hashtag create a figure with subplots. Fig. Axis equals plt.subplots, 2, 2. Fig size equals 10, 10. Axis equals axis.flatten. For I, sigma in enumerate, sigmas. Blurred underscore image equals scipi.endimage.gaussian underscore filter, image, sigma equals sigma. Axis I.imshow, blurred underscore image, map equals gray. Axis I.set underscore title, f sigma, sigma. plt.title underscore layout. plt.show. This code will display 4 subplots, each showing the image blurred with a different sigma value. Python inheritance, building upon existing classes. Inheritance is a fundamental concept in object-oriented programming, OOP, that allows you to create new classes, child or derived classes, based on existing classes, parent or base classes. This promotes code reusability and helps in organizing complex systems. How inheritance works. Base class, the parent class from which properties and methods are inherited. Derived class, the child class that inherits attributes and methods from the base class. Class animal. Def underscore underscore init underscore underscore, self, name. Self.name equals name. Def speak, self. Print, generic animal sound. Class dog, animal. Def speak, self. Print, woof. Class cat, animal. Def purr, self. Print, purring. In this example, animal is the base class with attributes and methods common to all animals. Dog and cat are derived classes inheriting from animal. Dog overrides the speak method to provide specific behavior for dogs. Cat inherits all attributes and methods from animal and adds a new method purr. Types of inheritance. Python supports various types of inheritance. Single inheritance, a class inherits from only one parent class. Multiple inheritance, a class inherits from multiple parent classes. Multilevel inheritance, a class inherits from a derived class. Hierarchical inheritance, multiple derived classes from a single base class. Hybrid inheritance, a combination of multiple types of inheritance. Key concepts. Overriding, redefining a method in a derived class to provide a different implementation. Super keyword, used to access methods of the parent class from a child class. Method resolution order, MRO determines the order in which methods are searched for in multiple inheritance scenarios. Example, overriding and super. Class shape. Def area, self. Pass. Class rectangle, shape. Def underscore underscore init underscore underscore, self, length, width. Self.length equals length. Self.width equals width. Def area, self. Return self.length asterisk self.width. Class square, rectangle. Def underscore underscore init underscore underscore, self, side. Super, dot underscore underscore init underscore underscore, side, side. Benefits of inheritance. Code reusability, avoids duplicate code. Hierarchical classification, organizes objects into related groups. Polymorphism, allows objects of different classes to be treated as objects of a common base class. When to use inheritance. When there's a clear is a relationship between classes, example a dog is an animal. When you want to share common attributes and methods among classes. When you need to extend the behavior of existing classes. Would you like to explore any specific aspect of inheritance in more detail, such as multiple inheritance, method resolution order, or real-world examples? Let's dive into multiple inheritance and method resolution order, MRO. Multiple inheritance is a powerful feature in Python, allowing a class to inherit attributes and methods from multiple parent classes. While it offers flexibility, it can also lead to complexities, especially when dealing with method resolution. Multiple inheritance example. Class animal. Def speak, self. Print, animal sound. Class flyable. Def fly, self. Print, flying. Class bat, animal, flyable. Pass. In this example, bat inherits from both animal and flyable, gaining the speak and fly methods. Method resolution order, MRO. MRO defines the order in which Python searches for methods in a class hierarchy. This becomes crucial in multiple inheritance to avoid ambiguity. Python uses C3 linearization to determine the MRO. Print, bat.mro, hashtag output, class __main __dot_bat, class __main __dot animal, class __main __dot flyable, class object. The MRO ensures that a class appears before its parents and that the order is consistent. Potential issues and best practices. Diamond problem. This occurs when a class inherits from two parents that share a common ancestor, leading to ambiguity. Python's MRO helps to mitigate this. Avoid excessive multiple inheritance. While it's powerful, overuse can make code harder to understand and maintain. Favor composition over inheritance. Sometimes, using composition, creating objects within a class, is a better approach than inheritance. Would you like to explore a specific use case for multiple inheritance or delve deeper into the C3 linearization algorithm? I can also provide examples of how to handle potential issues like the diamond problem. Use case, a user interface component. Imagine creating a user interface library. We have base classes for different types of components. Class widget. Def draw, self. Pass. Class focusable. Def set _focus, self. Pass. Def remove _focus, self. Pass. Now, we can create a button class that inherits from both widget and focusable. Class button, widget, focusable. Def __init self, text. Self.text equals text. Def draw, self. Print, F drawing button with text, self.text. In this scenario, multiple inheritance is useful because a button is both a visual component, inheriting from widget, and can receive focus, inheriting from focusable. Key points to consider. Even in this example, it's essential to design the classes carefully to avoid ambiguity. Consider using interfaces or abstract classes if the common behavior between classes is primarily about method signatures. For more complex scenarios, explore alternative approaches like composition or mixins.